Good day to Diana. My name is Shan from 3B KMS1, and today I'm going to share about my journey in 26 Malaysia. The industrial full name is 26 Malaysia Advanced Manufacturing Center, Sendirian Berhad, and my training period is from 21st July until 24th September of 2021. My industrial supervisor is Mr. Yap Chi Hong, whereas my faculty supervisor is Dr. Nordiana binti Nordin and Direct Musa. So this is the company background. So 26 Malaysia is a multinational company which the founder is the Dr. Vincent D. Matera. The headquarters is located at Sissenburg, Pennsylvania in USA. And in the branch Malaysia, the vice president is Jim Ling. The branch Malaysia is located at Ipoh Perak over the past 10 years with more than 3,000 headcount. In 26 Malaysia, the product they mainly produce is transceivable products for the photonics segment. Inside 26 Malaysia, they have a lot of departments such as tool ops, module test, labeling, and others else. This is the main product produced in the 26 Malaysia, which is optical transceiver and active optical cables. During my internship program, I'm assigned to the tool op, which we call second operation department. This is some picture of the production line, and my job inside during the internship is support machine development, feasibility study, data collection, and evaluation. Second op mainly for function as assembly process for different product. During the assembly process, there's a lot of processes such as fresh solder dipping, also broad assembly, and epoxy dispense, and other else to assembly the products. So inside the production line, everyone must follow the 26 corporate EHS standard, which is environment, health, and safety. So during my internship, I mainly learned about how to assembly the product, which is called QSSP28, and the main component to build up the QSSP is the OSA block, TOSA, transmitter optical sub-assembly, LOSA, receiver optical sub-assembly, OSA. This OSA is the combination of TOSA or LOSA with the OSA block, which is called optical sub-assembly, and the flex receiver circuit, PCBA printer circuit board, and epoxy. This is an example of epoxy. So this is the simply flow chart of the assembly process of QSP28. So first of all, the flex will took to solder dipping, and after solder dipping, we will assembly the OSA block, which I mentioned just now. We will took the TOSA or ROSA, combined with the OSA block by using epoxy. After that, the things will took to curing oven for curing process. And after that, this OSA block will took to the hot bar to attach with the flex. We go through the soldering dipping just now, and after that, this combination will go through the epoxy dispense again, and dispense between the flex. After this, we will took to the oven for curing process again, and after this, we'll go to the tagging process, which is tagging the flex on the combination with the PCBA. After that, we will tag this combination again to the hot bar to attach again flex and PCBA. And after this, the process, this combination will took to the X-ray station to check whether the combination have a failure or the match. So to make sure the module come out will not be malfunction or damaged or can be used. So if there is have failure, we will go through the rework station to rework the combination, and after that we will go to the final assembly to give the cover on the combination. Some tasks I given during my internship. So the first task is the shell assembly screwing process task, and in the cell assembly process, we have used a fixture, the screwing fixture I showed just now. So inside this fixture, the operator need to follow the work instruction. to do the process. So every unit must lock and unlock from the fixture, and screwing process must complete within the timer control. And no fixture in use for shell assembly process and non-standardization control reported. So we need to investigate the problem. So since the non-standardization control reported, and this might increase the possibility of component damage. Okay. So what I do during the task is I observe how the operators doing the process. So from my observation, I know that the performance of the timer is not shown at here because I don't have a picture. So the performance of timer is like 7 seconds with the setting by the engineer in 10 seconds. So 3 screws interaction finish within the timer control. The screw is right here. And to reactivate the fixtures, the operator just need to open and close the cover. This is the cover. Can push and close and open. Other from my observation, I also get some validation from the related engineer and the person in charge. So the operator can finish the task within the timer control, so there is no issues because it's not less than the 10 seconds, so there's no issue. So to reactive the features is slightly different with the statement. It's because the current sensor will fix to the detect the door close only. So from the uptime, okay, we know that the features is in use, but just the system is slightly different with the statement. Is because the thing is haven't updated yet. So to update the system, the engineer need to do action, so the system will function as per step. This is a task 2. Task 2 is doing some evaluation on body. So span is one of an important process in the assembly module. So epoxy actually play important role in build the OSA or the epoxy dispense between the flags I mentioned just now. So this is very important to for us to do some alternative epoxy evaluation to improve the sustainability and the strength of the module, and also save the cost of the company. So in this case, we use this one I called it SR4 epoxy, and this one I called it a H2OS epoxy to do the evaluation for the QSP Plus product. So from this task, I have studied about the technical data specification (TDS), and this is the data I collect from the TDS. Okay, so beside that, the post-sport specification for the QSP Plus process is also like the post-sport minimum apply is 20 Newton. Okay, beside that, I also do some physical hands-on on the OSA block to test the strength of the epoxy. So by using this IMADA machine, the process is like we put the OSA block. There's no picture for OSA block because configuration issue. So I put the OSA block on this picture. After that, I will click this down button, and the machine will go down automatically. Until the OSA will break. After the OSA broke, there will have a Newton value shown in the digital board, so we can know that how much the OSA can stand with the strength. Okay, so the result will be recorded and analysis. So from the TDS, we can know that the strength or H2OS is stronger than SR4. H2OS is more efficiency than the SR4 because the cure condition is like 1 hour and 150 degrees Celsius, which is lower than the SR4. And because of the higher temperature might damage the component, so the H2OS is efficiency than the SR4. So although the working life of SR4 is shorter than the H2OS, but we will do some physical hands-on. Okay, after that, the H2OS is easy to keep than the SR4 because the shelf life of H2OS is in 1 year at the room temperature. However, the SR4 is negative 40 degrees Celsius, which is hard to keep. We need to always keep it in a cold place. This is the data correction and evaluation from the physical hands-on, and we can see that the H2OS can stand with the higher load comparing to the SR4. So we can see the H2OS actually is stronger than the SR4. So however, by referring the push test specification, we know that the minimum is 20 Newton, right? So SR4 is actually require it actually fill the requirement of the push force specification. So we can know that the SR4 actually can be the alternative epoxy also, since it fill up the requirement. Okay. Although the TTS show that the SR4 is weaker than the H2OS. This is the third task I doing during my internship. So every epoxy has working time. The working time is like a duration of the epoxy to get stiff. So every epoxy will get stiff after some time. So when the epoxy over the working time is not stable to use, then we need to throw the epoxy. Okay, so they will have a wettage on the epoxy every day inside the production line. So we need to investigate how much the wettage inside the production line during the epoxy dispensing. Okay, so yeah. This is the observation and data correction I did in the production line. So we observed that how much mixture tube used in the production line per shift. So this is the data. Okay. So we also know that the mixture tube change whenever they change the strength inside the machine. So inside the mixture tube, every mixture tube have a leftover inside. So the epoxy wettage depends on how many robotic arm being used at one time. So the filled up mixture tube only support 2 gray per string, since there is only 2 robotic arm in operation. After that, we also took the mixture tube to measure to calculate the epoxy wettage inside the mixture tube. So before filling the epoxy, the mass is 5.3 something, and the final mass after we fill in the epoxy, after we use the epoxy, the left is like 10.47. So the epoxy wettage is like 5.1 gram something. Okay. So the quantity of mixture still depends on the OSA loading, since it's every day is different quantity of things that needed. So we cannot assume that there is a constant wettage inside the production line every day. So okay, the mixture tube usually when observation is low because the loading is soft. Okay, although the loading is not fixed, there has still wettage, epoxy wettage. By using the analytical balance ABT from currents, we can conclude that there's about 5 grams of epoxy wettage occur in each of the mixture tube. Therefore, the related engineer and person in charge will take part and continue to solve the epoxy wettage problem. So this is the last task I do during my internship. So there's always have sample in production line for engineer to do some data or data collection of evaluation purpose. For example, the sample of OSA. So this sample need to be reworked and repressed with new epoxy for evaluation. This sample need to be clean and not damaged, since the TOSA and ROSA is very expensive, and we need to remove the OSA block from the OSA to fill in the new epoxy to make the evaluation. Okay, so the procedure to rework the OSA is shown like this. So first of all, the OSA will put in this fixture, or put in here. After that, we will press down this thing, and then we just hold it. After that, we use this hardcore hot air reverse station to melt the epoxy between the dorsa and ossa block. After that, the ossa will disassembly disassembly. After that, we will remove the receptacles by using this clipper. And after we remove the ossa block from the ossa, we will took the dorsa or ossa to rework with the new ossa block. Okay, we will took it to the epoxy dispensing and then carving. So the dorsa and ossa will fill in with this new epoxy, the ossa block. After that, put in this picture. After this, putting in this picture, we will took it into this XL0343 module for carrying. After carrying 1 hour, the new ossa can be built, and we can do the push test again to do the evaluation. So this outcome is everyone must follow the 26 corporate EHS standard while stay inside the production line, because it's dangerous while using the instrument inside the production line. Example, for the hardcore, it's very high temperatures like 450, so it might hurt ourselves, so we need to be careful. So, and also while dispensing the epoxy, we need to follow the SOP, standard operation procedure of the process, so the component will not damage and the module will not malfunction. Okay. So the summary is there's a lot of process for QSP28 module assembly inside the throughout production line. Besides understand the details of process flow, we also need to have critical thinking when we're facing a problem. We need to understand the proper statement and come out with a proper effective concept or solution. Okay, this is task 1, task 2, task 3, task 4. Okay, this I want to. Okay, so I think that's all from me. Thank you for listening my presentation, and thank you for the institution, UTEM, giving this precious opportunity for me. Went to the 26 Malaysia for this internship program. Okay, that's all from me. Thank you.